Let's talk about modeling with functions. This is probably one of the most important things that you could get out of an algebra class because it's where we actually use algebra, we use math to model real world problems. The first one I have here, I said Ruben has been monitoring the stock market for weeks. He noticed the square root of the input -2 and then adding 3 closely modeled all of his data points. So we're going to write a function that describes a relationship and then graph it. And what we could do with this is this would allow us in the real world to make predictions based on what's happening in the graph. All right, so starting off, let's just pick, I'm going to say r of x. You can use any letter here, though it doesn't matter, any variable. So he noticed the square root of the input -2, so I would say square root of x -2. We always want to use x for the input. And then adding 3, so +3. That models his data points. So the parent function for this is square root of x. Just sketching that here on the graph. And this is actually transformed to the right 2. Remember, this is opposite inside of that square root bracket. So this is going right 2 and then up 3. We're going to go over 1, 2, and then up 1, 2, 3. Right there would be our new point. So you're going to get something kind of like that. All right, so what are the domain and range for this? Domain is just what are all the possible x values. You can tell x starts here at 2 and then just gets bigger from there. So I could say x is greater than or equal to 2. For range means what are all the possible y values. So y is starting here at 1, 2, 3, and just going up from there. Y is greater than or equal to 3, which you might also notice these are the same numbers that are in here, 2 and 3. Okay, let's do one more. So here I said Jared is testing and logging the emissions from several different diesel engines. He noticed that the exhaust data points seem to follow a pattern. He noticed the negative cube root of the input +2 and then subtracting 4 seems to follow the data. So here I'm going to say j of x, and we're talking about the negative cube root. So this is going to be negative radical, and it's with a little 3 here for cube root of the input +2. So I could say x +2 and then subtracting 4. That's going to model our data. And the parent function for this would just be the cube root of x. So if you remember that parent function, let me do that in black. For the cube root of x kind of looked something like this. And this is going to be reflected because of this negative sign out here. It's going to be reflected upside down. And we are also translating left 2, remember this is opposite, left 2, and then down 4. So 1, 2, 1, 2, 3, 4. The new vertex would be right there. And again, this is also reflected because of this negative sign that's multiplying. So I would sketch that just like this. Okay, and just like before, this is asking us what is the domain, what is the range domain, all the possible x values. These just keep going all the way to the left, all the way to the right. So x can really be any number. I'm going to use that fancy r with a line through it. This just means x equals all real numbers. And same thing for the y. There's no restrictions here on the y. Y keeps going on forever in the direction of these arrows. So y is also all real numbers. There's no gaps or anything here in the graph. All right. So that's basically it. I just wanted to go over those 2 examples of how we can use algebra to model real world problems.